Hey class, the day's over. Sixth period is left. Let's take a quick review of kind of the big idea for today. So we concluded our day with this idea of having equations that we can solve using a technique we're calling fraction busters. And so, for example, if I have the equation 12 over 7x plus 3 over x equals 5 over 7. Just made this up. Just pick this particular equation. One of the things I can do is I can kind of pick off these fractions, break them up one at a time, or I can do them all at once. I'm going to do them in two steps here, and I'm going to begin by multiplying both sides of this equation by the number 7 and observing what happens. So if I put a factor of 7 in this first term, it becomes 7 times 12 over 7x plus 7 times 3 over x equals 7 times 5 over 7. So what I've done is these 7s, that 7 and this 7, represents the fact that each term across that entire equation received a new factor of 7. Now, what I can do because of that is you can see this created a giant 1. This created the number 1. So this equation can be rewritten in the somewhat more simple form, 12 over x plus, I'll write 21 over x equals the number 5. So by pushing across that factor of 7 across all terms, I got a new equation that no longer has 7 in the denominator. I still have this variable x in the denominator, but I'm going to fix that with my next step. I'm going to choose to push across a new factor of x across all three terms. There's two terms on the left-hand side, one term on the right. This is going to become x times 12 over x plus x times 21 over x equals 5 times x, or x times 5. Again, new things that showed up, right? This x, and this x were all pushed across the equation. Every single one of those terms in the previous step got a new factor of x. My motivation for doing that and the benefit of doing that is now this is a giant 1, this is a 1, and those are no longer fractions. So this equation becomes 12 plus 21 is the number 5. That looks like 12 and 21 would be 33. 33 is 5. Therefore, x, wait a minute. What did I just do? As 5, this is a 5x. I forgot the exit was going here. Therefore, 33 divided by 5 is what x is. That's a likely story. The question is that really true? Does 33/5 satisfy the original equation? So to check that, I'm going to go over to my calculator, and I want to take 33/5. So 33, oops, I have to go over here. 33 over 5, that's 33/5. And I'm going to, I'll just store that in x. So you can see how I did that, right? I entered the 33/5, and you can press enter there if you want to. Once that's on the stack, I see the 33/5. I can now say store that as x. So this calculator thinks x is 33/5. If I press x, it will just repeat that to me. Oh, x, that's 33/5. So let's see what it says when I take 12 over 7x. Leave this fraction, and I want to now add 3 over x. So I'm curious to see what that becomes. Well, according to my calculator, that equals 5/7. So what's wonderful about that is I can see now from my calculator's display that this side of the equation becomes 5/7 when x is 33/5, and the other side was already 5/7. So definitely when x is 33/5, both sides of that equation becomes 5/7. So that's another quick look at this idea of busting up fractions, fraction busters. Talk to you tomorrow.